Welcome to aminacademy.com. In chemistry, let us discuss about energy transfer. First, we will discuss energy as heat. Energy transfer is the process by which the energy is relocated from one system to another. For example, through the transfer of heat, work, or mass transfer. Look at here. Here, that heat energy is transferred to heat the water through the vessel. Heat energy is the result of the movement of tiny particles called atoms, molecules, or ions in solids, liquid and gases. Heat energy can be transferred from one object to another. The transfer or flow due to the difference in temperature between the two objects is called heat. A sample can transfer energy to another sample. Some example of energy transfer as the electric current in a wire, a beam of light, a moving piston, and a flame used by a welder. These are energy transfer examples. Though energy has many different forms, all energy is measured in units called joules. So the amount of energy that one sample transfers to another sample as heat is measured in joules. Energy is never created or destroyed. The amount of energy transferred from one sample must be equal to the amount of energy received by the second sample. Therefore, the total energy of the two samples remains exactly the same. Now, let us discuss what is temperature. Temperature is a physical quantity that expresses quantitatively the perceptions of hotness and coldness. Temperature is measured with thermometer. When sample of different temperatures are in contact, energy is transferred from the sample that has higher temperature to the sample that has the lower temperature. The temperature increase of a sample also depends on the mass of the sample. For example, the liquid is both in the beakers. Initially 10 degrees Celsius, the equal quantities of energy were transferred to each beaker. The temperature increase in the beaker on the one side, that is only about one half of the temperature, and the beaker other side. Suppose the amount of water is more, the temperature is less. Heat and temperature difference. The core difference is that heat deals with thermal energy, whereas temperature is more concerned with the molecular kinetic energy. Heat is the transfer of thermal energy, whereas the temperature is a property of object exhibits. Here it looks heat, this measures the temperature of the heat. Heat is the total energy of the motion of the molecules inside the object or particles, whereas the temperature is merely a measure of this energy. The relationship could be the more heated an object is, the higher the temperature the object will have. You know that the heat and temperature are different because you know that when two samples of different temperatures are in contact, energy can be transferred as heat. Heat and temperature differ in other ways. Temperature is an intensive property, which means that the temperature of a sample does not depend on the amount of the sample. However, heat is an extensive property, which means that the amount of energy transfer as heat by a sample depends on the amount of samples also. So, water in a glass and water in a pitcher can have the same temperature, but the water in the pitcher can transfer more energy as heat to another sample because the water in the pitcher has more particles than the water in the glass. Next we will talk about enthalpy. Enthalpy, normally denoted H, capital H, is a thermodynamic property. It is equal to the sum of the internal energy plus the product of the pressure and volume. that is enthalpy H equal to U plus PV. U is internal energy, P is pressure, V is volume. Changes in enthalpy during heating and cooling operations are important. The change in enthalpy delta H is given by delta H equal to delta U plus delta PV. Now we'll discuss further. All matter contains energy. Measuring the total amount of energy present in a sample of matter is impossible, but changes in energy content can be determined. These changes are determined by measuring the energy that enters or leaves the sample. For example, if 73 joule of energy enter a piece of silver and no change in pressure occurs, we know that the enthalpy of the silver has increased. Therefore, increased by 73 joules. Enthalpy, which is represented by the symbol H, is the total energy content of a sample. If pressure remains constant, the enthalpy increase of a sample of matter equals the energy as heat that is received. This relationship remains true even when a chemical reaction or change of state occurs. A sample's enthalpy includes the kinetic energy of its particle. The particles in a sample are in constant motion. In other words, these particles have kinetic energy. You know that the enthalpy of a sample is the energy that sample has. So the enthalpy of a sample also includes the total kinetic energy of its particles. Imagine a gold ring being cooled. As the ring transfers energy as heat to its surroundings, there is a decrease in the motion of the atoms that make up the gold ring. The kinetic energy of the atoms decreases. As the total kinetic energy decreases, the enthalpy of the ring decreases. This decrease in a kinetic energy is observed as a decrease in temperature. Next, we'll discuss about molar heat capacity. Molar heat capacity is defined as the amount of heat required to raise 1 mole of a substance by 1 degree Kelvin. Molar heat capacity is very similar to a specific heat capacity but measured per mole instead of per gram of a substance. For a gas, Q, molar heat capacity Q equal to Nc delta T, where N equal to number of moles and C equal to molar specific heat and delta T is change in temperature. The molar heat capacity of a pure substance is the energy as heat needed to increase the temperature of 1 mole of the substance in 1 degree Kelvin. Here, for further, we'll do some example problem regarding molar heat capacity. Determine the energy as heat needed to increase the temperature of 25 mole of mercury by 8 Kelvin. The value of C for mercury is 27.8 joules per Kelvin mole, sorry. Now we'll start the problem here. Here, Q equal formula. Let us do some solving problem. Determine the energy as heat needed to increase the temperature of 25 mole of mercury by 8 degree Kelvin. The value of C for mercury is 27.8 joules per Kelvin mole. Here the given thing, the formula is Q equal NC delta T. Therefore, which is equal 25 into 27.8 delta T equal 8 degree Kelvin. This coefficient gives 5560 joules, which is converted to kilojoule equal 5.560 kilojoule. Now, second question. A 0.075 mole of octane C8H18 absorbed 3550 joules of energy. Calculate the temperature increase of octane if the molar heat capacity of octane is 254 joules per kilomole. The given is mole of octane is given and heat energy is given. We have to calculate temperature increase. Here the formula is delta T equal Q over NC, which is Q equal 3550 over number of moles is 0.075 into heat capacity is 254, which gives 186 degree Kelvin. Therefore, the temperature increase of octane is 186 degree Kelvin. We have done. Please subscribe our YouTube channel.